This switch statement is another conditional structure. It is a good alternative of nested if-else. It can be used easily when there are many choices available and only one should be executed. Nested if becomes very difficult in such conditions. The nested if-else statement allows you to execute a block code among many alternatives. If you are checking on the value of a single variable in nested if-else statement, it is better to use switch statement. The switch statement is often faster than nested if-else. Also, the syntax of switch statement is clear and easier to understand, which is C++ provides the multi-way decision statement which helps to decrease the complexity of the program. Switch case statement is best way to deal with the else if nesting conditions. For example, if we have if else something like if condition 1 statement 1 else statement 2 if condition 2 if condition 3 statement 3 else if condition 4 statement 4 else statement 5. It is a little bit difficult to understand and to find the flow of the program. So instead of this nested as if statements, if we write it as consider the above scenario, we can overcome this situation by using the switch case statement syntax like below, which is instead of writing if, we use keyword switch then expression, then into that switch we write case value 1 and the body 1, then break, then case value 2 body 2 break, case value 3 body 3 break, and the default body and then break, and then to the next statements. So for each if statement we write a case value, and for last else we write a default body. So the flow diagram of a switch structure is as switch statement compares the result of a single expression with multiple cases. Expression can be any valid expression that results in integer or character value. The expression is evaluated at the top of switch statement and it results is compared with different cases. Each case represents one choice. If the result matches with any case, the corresponding block of statement is executed. Any number of cases can be used in one switch statement. So switch 2, then we write case 1. For the case 1 we write the statement 1, then after if we complete our case 1 then we insert a break, and if for case 2 we write statement 2. Similarly for case 3 we write statement 3, and in the last we write the statement n, which is a default statement. The syntax of C++ case switch statement is the syntax of for the writing the structure is as followed. First switch, then into expression, This expression is any integer or a character variable. So here we write switch n represent any variable, any integer or a character value. Then we insert curly braces, and in these curly braces we write our case. First case constant 1, this one integer or character constant mean we instead of 1 we use any character. So for after that statements first body, then the break causes exit from the body. Mean if our first case becomes true, then the code to be executed if n is equal to constant 1, and no need we execute the remaining cases, so we insert a break here. But if our first case is false, then we write the second case statement, which is case constant, and in front of case constant we write any integer or a character. Here we write a 2, mean 1 to integer value. Then we write second case body, which is code and the break statement. Similarly, for the case n constant, case constant for n mean n times case, then we write the body of the n case body, and at the end we write default, then and the body of the default. After that we close the curly braces. When a case constant is found that matches the switch expression, control of the program passes to the block of code associated with that case. In the above pseudocode, suppose the value of n is equal to constant 2. The compiler will execute the block of code associated with the case statement until the end of the switch block or until the break statement is encountered. The break statement is used to prevent the code running into the next case. So here is the flow chart of our case statement. Single expression after single expression equal to the case constant 1. If it is our single expression is equal to the case statement 1, then we enter into the case statement 1 body, and the case statement 1 body executes. After executing the case body 1, it goes to the break, and we come out of the case body. But if it is not equal to case constant 1, then it enter into the case constant 2, where condition is checked. If condition is true, then we enter into the code block of case constant 2. If condition is not, then we check the case constant of 3. If the expression of case constant 3 is true, then we enter into the body of the code block 3. If the case constant 3 is not true, then we goes on further case constants. If all case constants are false, then the default code executes. The break statement in each case is used to exit from switch body. It is used at the end of each case block. When the result of the expression matches with the case block, the corresponding statements are executed. The break statement comes after these statements and the control exits from switch body. If break is not used, all case blocks that comes after the matching case will also be executed. Another thing is the default label. The default label appear at the end of all case blocks. It is executed only when the result of expression does not match with any case label it used is optional. The position of default label is not fixed. It may be placed before the first case statement or after the last one. For the break statement, the syntax of break statement is the keyword break and with the semicolon. And the syntax of a default label is the keyword default with the colon. Now we have a problem. We want to write a C++ program which determines that either enter letter is a vowel or a constant. So let's code it. Into the main program, we declare a variable C whose data type is a char because we want an alphabet to be entered by the user. So cout enter alphabet and then user enter the alphabet. Then we convert the uppercase letters into the lowercase letters. So after that we place switch statements and into the switch statement expression we pass the our variable which is C. So first of all we check either we enter a vowel character or a constant character. We know that A, E, I, O, U, these five alphabets are vowel characters and the rest of alphabets are considered to be as a constant alphabets, constant characters. So first case is A. For first vowel we so case A we which means we match this A with the entered alphabet which is stored in variable C. If A matches with the entered alphabet, then it prints the output. You enter A, it's a vowel, and then we insert break because we want to exit from our case. But if we enter a different character from A, then we have another check for vowel which is E. If case E, it means E, if E is equal to C, then we enter into our case body which where we write you enter E, it is a vowel and then it breaks. If case E is false, then have another vowel case that is I. So in case I, if it is true, it means I is equal to C. It prints on the screen that you enter I, it's a vowel. If this statement is false, then we have another case which is 0. Oh, sorry, O. O is another vowel. In case O means O is equal to C. If it is true, then it prints on the screen you enter O, it is a vowel. If this condition is false, then we have another case which is case U. If it is true, it prints on the screen you enter U, it is a vowel. So we, for vowels numbers, we have all A, E, I, O, U cases, and if all these cases are false, then we enter a default case or default statement or default label. In default label, we enter that you enter a constant. So here is the output of our program. Program asked us to enter an alphabet. If user enter an alphabet like A, E, I, O, U, it enter into the case statement and prints. For example, if we enter A, it shows on the screen you entered A, it is a vowel. But if we enter another number rather than A, E, I, O, U, then all cases becomes false and the default label executes. Under the default label, we write you entered a constant. Multiple selections problem. In this problem, we want to develop a calculator which is able to handle two numbers. The calculator can perform addition, subtraction, multiplication, division, and remainder. So we want to develop a simple calculator. We have cases addition, subtraction, multiplication, division, and remainder. First of all, into the main program, we declare two numbers, first number and second number, and a character operator choice. For the operator choice, mean either he want addition, subtraction, multiplication, or division or remainder. Then we ask user to enter first number, then we ask user to enter second number, then we ask user to enter a operator. After entering first number, second number, and the operator, we insert switch statement on the operator choice. If we want addition and you use addition, then in case we have first case of addition. Under case of addition, we simply print the addition of two numbers entered by the user, mean first number plus second number. If this case is true, then there is a break at the end of this case. If this is case, then we enter into the second case, which is a negative, subtraction case. In subtraction case, we subtract first number into from the second number. If they so false, then we enter into the multiplication case and we multiply first number with second number. If this case is false, then we have write another case for the for the division. In this number, we divide first number from second number, and if for the remainder, we have a remainder case which shows us the remainder of after dividing first number from second number. If we use another operator, then we have a default label. under default label, we want to show the user that he chooses an invalid operator. The output of the previous program. Program asked user to enter the first number. For example, user enter 4. When he asked user to enter second number and user enter 5 number, then he asked user to enter the operator, and user have a selection from plus, minus, multiplication, division and modulus operators. For example, user choose multiplication, then it enters into the multiplication case and it multiplies the numbers 4 multiplied by 5 and is equal to 20. In other case, enter first number 21, enter second number 5, enter operator. Now user choose modulus operator, then it gives us the remainder after dividing 21 over 5. So here is a rules table for switch statement. In this table we have valid switch statements and invalid switch statements. In valid switch statements we have switch A greater than B, switch A plus B minus 2, switch function A into B. And invalid switches we have switch 2.3 or switch A plus 2.3. Similarly for valid cases, so it clears us that we didn't use so this table tells us that we are not allowed to use point numbers into switch statements. Similarly, after switch statement we have case statements, and we have valid case statements and invalid case statements. In valid case statements we may write case 3, case A, case 1 plus 2, case A greater than B. And invalid cases we have point numbers, for example case 2.5, for example case x plus 2, case 1 to 3. So these are the some of the rules table for switch statements and for case statement. The following rule applies to a switch statement. Case label must be unique. Case label must ends with colon. Case label must have constants and constant expressions. Case label must be of integral type, means integer character. Switch case should have at most one default label. Default label is optional. Default can be placed anywhere in the switch. Break statements takes control out of the switch. Two or more cases may share one break statement. Nesting switch within switch is allowed. Rational operators are not allowed in switch statements. Macro identifier are allowed as switch case label. Constant variable is allowed in switch case statements. Empty switch case is allowed. Let's have another problem. The problem statement is a bank gives loan in two situations. First, if customer is male and his age is more than 25 and his salary is more than 25,000. Number two, if customer is female and her age is more than 30 and her income is more than 20,000. In program, ask user to enter age, gender, and income. Check whether he and she is eligible to get loan or not. So for this problem, into the main body, we need three variables, one for age, one for income, one for gender. So we declare age and income variable as integer type and gender as a character type. Then program ask user to enter the name, ask user to enter the income, and then ask user to enter the gender. Then we have if statement, if age is greater than 25 and gender is equal to male and income greater than 25,000, then see out, sir, you can apply for loan. As if age greater than 30 and gender is equal to F and income greater than 30,000, then program says, madam, you can apply for loan. Else see out, you are not eligible for loan. So this is a simple which write a C++ program to check percentage of a student and display division. This program asks the percentage of a student and display which division she has got. The criteria of division is displayed as if the percentage is greater than or equal to 80, then this section, if greater than 60 and less than 80, then he or she got first division. If the percentage is greater than 50 and less than 60, then he and she got second division. If percentage is greater than 40 and less than 50, then he or she get third division. And in the last, if the percentage is less than 40, then he and she gets fail. So for this program, the output should look like this according to the condition. A switch case is created and the result are displayed. Enter your percentage. For example, we enter 89. Your score 89%. You have passed with distinction. Enter your percentage. If we enter 47, you score 47. You have passed with third division. It is possible to have a switch as part of the statement sequence of an outer switch, even if the case constants of the inner and outer switch contains common values. No conflict will arise. C++ specified that at least 256 levels of nesting be allowed for switch statements. Syntax. The syntax of nested switch statement is as follows. Program this problem, we use switch statements. We use switch on the variable of in a case A, see out, this A is part of outer switch. For nested case 2, case A, this A is part of inner switch. So this nested switch statements tell us how to initialize a switch statement into another switch statement. First of all, we need a variable. We declare variable A and store 100 in it, and we declare a variable B with and store 200 in it. Then we use switch statement, and under switch statement we write case 100 if this is a part of the outer switch, and before exiting our switch statement we write another switch statement into our previous switch statement, which is switch B and case 200, and in that we write this is part of inner switch. Then it displays exact value of A and exact value of B. So the output of previous program look like this: the part of the outer switch, the part of the inner switch, the exact value of A is 100 and the exact value of B is 200. Basically it tells us how nested switch works. Conditional and are ternary operator. A ternary operator operates on three operands, which can be used instead of a if-else statement. For example, if A less than B, then A is equal to B, else A is equal to minus B. We can replace the above code with a ternary operator, which is as A is equal to A less than B, otherwise B is equal to minus B. The ternary operator is more readable than a if-else statement for short conditions. Example of a ternary operator. In this example, we declare in our main program number 1 and store value 4 in it, number 2 and store value 5 in it, and then a variable number. Then we write num is equal to number 2 greater than number 1. If it is true, number 2 is equal to number 1. See out the greater number is number and all. So this returns us the greater number is 5. In this example, if the condition number 2 greater than number 1 is true, then number 2 shows on the screen, means 5 will get assigned to num. Otherwise, number 1 means 4 will get assigned to num variable. In our case, the value of num1 and num2 are 4 and 5 respectively. Thus, the condition num2 greater than num1 is true, and the value of num2 mean 5 got assigned to num, and so the greater number is 5 printed on the screen. Thank you.